Hope I am audible, and my screen is also visible.
Yes, sir.
Thank you. So let's wait for another 1-2 minutes. Let's see if more people join, then we can start. Okay, so let's start with the week 11 assignments problem. So we will solve the numericals that has been given in the assignments. So let's start with the question 4. In this question, what they're asking is that, like, suppose we have trained a weather classifier with 5 classes: sunny, windy, rainy, foggy, and clear. Consider. Okay, so if you followed the this lecture of the Professor Pawan Goyal sir, then you already know that when someone gives you a confusion matrix. So basically, what is the confusion matrix? So for a specific classification class, so you have a goal level and your model will predict some outcome. Okay, so the matrix, in this confusion matrix, you will represent that thing only. So what is your goal level and what your model output. So this is like a confusion matrix. So if you see in this confusion matrix in the table 1, so each row is like, if you consider the first row, it is about the sunny. So basically, number of times sunny has been predicted, and the columns are for the goal level. So basically, the first cell, if you want to if you see the first cell 130, it means that, like, now there are 130 times. So when the actual level is gold and prediction level is also, like, sorry, actual level is sunny and the prediction is also sunny. Similarly, if you check the second cell, it is like, uh, so there are 17 times when the gold level is windy, but your prediction model predicted sunny. Okay, and if you just, and so on and so forth. If you just check other, if you, let's check this row, this clear and rainy. So basically, this row says there are 20 times when the gold level is rainy, but your model predicted clear. Okay, so this is a confusion matrix, and given this confusion matrix, they are asking 5 different questions. So what is the first question? So they are asking you, what is the macro average precision? Now, if you recall, so to calculate the macro, so there is 2 ways to calculate the precision. One is this, like, micro and macro. So first one they are asking is that macro average precision. So there are another ways like weighted average and all these things. So mainly macro and micro they are asking in this question. So in the first question they are asking about the macro average precision. So how you calculate the macro? So to calculate the macro average precision, you need to calculate the confusion matrix for each of this class separately. Okay, so in this table, if you see the confusion matrix, it is like, all the class levels are given, but now to calculate the macro average precision, you need to calculate the confusion matrix for each of this individual class. Okay, so how can you do that? Let's take a look. Okay, so I think it is very easy. So still, let's take a look. So how can, so basically this is a long problem, so just bear with me. So this is the table so given. Okay, so this is the table given, and there are 5 such columns and rows. If you just follow, this is your given confusion matrix. So in this side, this is a prediction, and in the upper this is actual, so or gold, whatever you want to say. And there are 5 different weathers, which is sunny, windy, rainy, foggy, clear. Sunny, windy, rainy, foggy, and clear. Similarly here also sunny, windy, rainy, foggy, and clear. Now let's fill up the cells. So the values are already given: 130, 70, 9, 740. Just wait for a minute, I'm just filling it. 137, 9, 137, 9, 740. 15, 150. 25, 10, 17. 10, 45, 150. 23, 5. 15, 15, 20. 15, 15, 20, 120, 30, I guess. It's 40, 30, 20, 10. 40, 30, 20, 10, 150. Okay, so this is the given table. Now we will like construct the individual table for each of this weather. Okay, so how to construct? Let's see. So let's start with the weather sunny. Okay, so so this is the given thing. So let's start with the sunny. So we want to construct the for sunny. Okay, let's do it like this way. Okay, so similarly for this way also, so let's mark the column as gold, and this rows are red, and let's write it like this way. So true, false, true, false. So this means, so what is this true means? So true means like this prediction. True means like your model predicted sunny, and F means your model not predicted sunny. Okay, and similarly for gold, true means it is actually sunny, and false means it is not sunny. Okay, so actually it's not sunny. So how to construct this table? Now in the first cell, it is true. So basically actual is also sunny and prediction is also sunny. So let's check from this table only. So this is the thing. So 130. So actual is also sunny and prediction is also sunny. So this will be 130. Okay. Now let's move to this cell, second cell. So what is this cell? Prediction is sunny, but actual, in reality, it is not sunny. Okay. So how to calculate this thing from the actual table? Okay. So basically, so if you just this thing, so basically what is this thing? So this thing is, so actual your model predicted sunny, but in reality the predictions are not sunny. Okay, so this is how to check it from this actual table. So if you check this row only, if you check this row, so basically what this row indicates in the actual table. So this table shows ki a number of times your model predicted sunny given all the real values. Okay, so actual gold level. So the first row, first cell says in your model predicted sunny, and here also the gold level is also sunny. Second cell says ki your model predicted sunny, but the gold prediction is windy. The third row says ki the gold level is sunny, but sorry, the prediction is sunny, but the gold level is rainy, and so on and so forth. Okay, so you can use this information to calculate this thing. So basically what this cell says ki the total number of prediction, total pred, where pred equal to sunny, but gold not sunny. Okay, so I'm just writing it as a tilde to make indicate ki it is not sunny. Okay. So this cell indicate this thing. Okay. So how to calculate this thing only? So this is basically this is the sum of all this. Okay, it is the sum of all these values. So all this rows value. So basically this is like your model predicted sunny, but the actual levels are not sunny. If you just take this summation of these four cells. Okay, so if you just sum it is 47 and 9 what is 56 and 17 66 and 73. Okay, so it will be 73. Okay. Similarly, if you want to check what is this cell mean, this cell mean is the total predictions, basically where prediction is not sunny, but gold level is sunny. Okay, if you just see, so gold level is sunny, but prediction is false. So prediction is false means it is not sunny. So that's why I'm writing like this way. So prediction is not sunny, but gold is sunny. So how to calculate the value for this cell from the actual table? Same, you just need to calculate the sum of these four cells. Okay, in these four cells, so it is like so basically, yeah, what is this row suggest? So what is this column suggest? The total number of goal prediction for sunny. Okay, but if you just delete this cell, ignore this cell, so this suggests ki the goal level is sunny, but your prediction is not sunny. Okay, so this prediction is from windy, rainy, foggy, and clear. So just you need to sum up these four cells, and this will be your entry for this cell. So just sum up this. So it will be 25 10 20 sorry 15 10 25 25 5, 30 40 80. So it will be 80. And whatever the last cell, it is like total prediction. It is total prediction where prediction is also not sunny, and gold also not sunny. Okay, so both are not sunny. So this is the last cell. So gold, the actual prediction is also not sunny, and actual level is also not sunny, and the prediction is also not sunny. So how to calculate this from the actual table? So basically this is the, if you just ignore the first row and first column, this is basically this part. This is basically this part. So in this part, if you just check, so basically in this part, if you just check, basically it is suggesting the actual level is also not sunny. Actual level is also not sunny, and prediction is also not sunny. So if you just check these cells, all these cells, so it is not like they are involving other weathers but not sunny. Okay, so basically if you need to sum up all these this 16 cells, 1 2 3 4, yeah, so 4 cross 4, this is a 4 cross 4 matrix, so 16 cells. So you just need to sum up these 4 cells. This will give you the value for the last one. So if you do this sum, actually I already summed it up. So basically this is this is basically 815. Basically this is 81. Okay, so this is the table for sun. Okay, this is the table for sun. So also another thing to be noted, from this, so how many total entries are there in the total 5 cross? So this is a 5 cross 5 matrix. So this is a 5 cross 5 matrix. So there are total 25 cells. So in this 25 cells, so what is the total number? So if you just calculate it, it will be 1098. Okay, so it will be 1098. Similarly, if you just sum up these 4 cells, also it will be give you this 109. So you can also calculate this likewise. So if you just calculate this and subtract it from 1098, you will get 815. Okay, I hope it is clear. So let's calculate for another weather, and it will be totally clear to all. Okay, so okay, so let's calculate for before that, let's erase the marking. So then it will be difficult for you to follow. Okay, I'm just erasing the marking. Okay, I already erased the marking, so let's mark it totally. I hope it is 30. Okay, so let's calculate for let's say what do you want to say? Let's second column say, let's say windy. Okay, so let's calculate for windy similar way. So it will be true, false, true, false. In the column, the rows are predictions and the columns are gold. Now do it like what about the first row? So the first row is both is like the actual prediction is also windy and the true gold level is also windy. So how to check it from the actual table? If you just check this row, this cell, so it is windy. So the actual is also windy and prediction is also windy. So it is 150. Okay, so this will be 150. Now what about this row? What about this cell? Now how to calculate, if you remember? Okay, so how to remember? So basically this what is this cell represent? So the total period. So where the prediction is windy, but the gold is not windy. So how to calculate this thing? Similar. So you just need to calculate. You just need to focus on this second row. So second row suggests. So what is the row represent in the actual table? Second row. Second row represents all the predictions about window. So all the number of predictions, total number of predictions for windy. Okay. Now if you just ignore the second this cell, So basically the second cell is windy, and also the gold prediction is windy. But if you just ignore this cell, all other values, so this all this 4, so this last 3 and the first one represent the prediction is windy but the gold level is not windy. Okay, so just you need to sum the other 4 value except the 150. Okay, so if you just do it, it will be 40, yeah, it is 40, 50, 57. So it will be 57. Similarly, what about this cell? So this is the total parade, where what is where parade actual parade is not windy but gold is windy. How to calculate it? So basically you need to calculate this row. So this row, so this column is about the gold prediction about windy, but the only thing you need to remove this cell, because this cell, in this cell the gold level is also windy and the prediction is also windy, but this row asks you to find the count where the gold level is windy but the prediction is not windy. So you just need to sum the whole column, but you need to deduct 150. Okay, so basically you need to sum these 4 cells, so the 17 and this last 3. Okay, so if you just sum me up, it will be what about this 50, 60, 90, 100, 107. It will be 107. Okay, and what about the last cell? So when both the predictions are wrong, so so both the prediction is also not windy and the gold is also not windy. So how to calculate this thing? So basically I already told you, if you just sum up the whole table, so it will be 1098. It will be 1098. Now from this 1098, if you just subtract 107, 150 and 57, you will get the value for this thing. So basically those, like these 4 cells are mutually exclusive. So it is not like there is a intersection between the cells. So if you just subtract the other cells value from this 180, you will get the count for the last cell. Okay, or else if you just want to calculate, you need to sum this 130. So basically you need to sum up all this thing except this, except the first row, sorry, so the second row and the second column, or you can just subtract from this 180. So it will be 780. Okay, so I hope the this thing is clear. So how to calculate the individual confusion matrix for individual weathers. Okay, now we need to calculate the precision, this micro precision. So what they are asking, so this macro average precision, all these things. So let's do it. Okay, so I already so just go to the next page. Sorry, go to the next page, and we already calculated the windy thing. So let's for each of this weather, I'm just drawing the cell. Okay, so this is true, false, true, false. This is true, false, true, false. This is for gold, and this is red. Similarly, let's do it for, so this is windy, so this is, let's do for sunny. So we already calculate all these things, so for calculation I'm again writing the value there. So it will be true, false, same. So this is red, this is gold. Similarly, let's do for another cell. Space is small, so there are 5 others, so there will be 5 such boxes. So let's, it is for rainy, it is red, and it is also cold. rainy and there is foggy. Okay, let's see. Foggy. So my writing is not that good, but yeah, it is. And the last is clear. So there is clear weather. This is great. So we already calculated the value for sunny and windy in the last slide. So I will just copy the value. So it will be 150, 57, 107, 784. For sunny it is 130, 73, 80, 185. Okay. So for rest of the entries we already calculated. I hope now you can calculate it like by yourself, but in the interest of time I'm not calculating them. I already know, so I'm just putting the values here. Okay, so it will be, you can check, it will be 150, 83, 74, 93, 931, and for foggy it will be 120, it will be 80, it will be 50, it will be 480. For clear it will be 155, 100, 82, 76. Okay. Now how we can calculate this thing? So the precision and recall. So how to calculate the precision and recall from this table? If you just recall the formula, so I'm just writing precision as P. Okay, so precision for windy. Okay. So what is the precision formula? So precision is number of time you predicted that thing. So for like, if you just take for the windy class, so for windy class, what is the formula? So formula is the number of time you predicted windy, but among them how many time actually it is really windy. Okay, so basically in the denominator, the total number of time you predicted windy. So what is the, then what will be the denominator? So total number of time you predicted windy. So basically this is the thing. So total number of time you predicted windy. Okay, so it will be this thing. So 150 plus 57. So 150. So for 150 plus 57, it will be 2. What is this thing? It will be 207. If you just sum this 150 plus 57, it will be 207. So total number of time you predicted windy. Okay, now what is the numerator? Numerator is like among 207, how many time actually it is windy. So what is the value? It is 2. So it is 150. So you predicted 207 time windy, but among them only 150 time it is true, actually windy. So this is the precision for windy class. Okay, you can calculate. It will be if you just it will be around 150 plus 150 by 2,000. It will be around 0.72. Similarly, what is the recall for windy? What is the formula? Formula basically, so total number of the total number of in the denominator, it is basically this column. So basically the total number of time it is actually windy. Okay, so total number of time. So the total number of time it is actually windy. So what is this value? It is 150 plus 107. Okay, so it will be 257. And what is the numerator? Numerator will be so same. Numerator will be same. So among these 257, how many time actually your prediction predicted it as windy? So it will be 150 same. So so if you just see the formula for precision and recall, so this P I am just representing for precision and this R for recall. So the only difference is in the denominator. For precision, so what this denominator is, so what the for the precision, the denominator is the number of, so the total number of time. So for like I'm just saying for windy class, so total number of time you predicted windy. Okay, so total number of time you predicted windy. So the denominator for precision. For the recall thing, it is the total number of time. The value is like the goal class is actually windy. So there is a difference. So the for precision thing, in the denominator total number of time you predicted windy, but for recall total number of time the goal class is windy. Okay, so this is the difference, but the numerator is same for both these things. So you just need to remember the difference. Okay, so if you just calculate this 150 by 257, it will be 0.58. Okay, similarly you can calculate the sunny for precision for sunny. So what is the precision for sunny? Let's calculate. If you just remember, so what is the formula for sunny? In the numerator is simple. So like I'm just writing for same thing. So the numerator for precision and recall are same. So it will be the true class. When the prediction and the goal level both are same. So this is the thing. So when the prediction and the goal both are same, so it is 130. So for precision it will be 130 and recall also it will be 130. But for denominator it is different. So what is the difference between this precision and recall? For precision, denominator is the total number of time you predicted sunny. So total number of time you predicted sunny. So basically this row. So this row. So total number of time you predicted sunny. So what is this sum? So 130 plus 73. 130 plus 73. It will be 203. It will be 203. And for the recall, what will be the denominator? It will be the actually how many time it is sunny. So it will be the first column. Okay. So for precision, the denominator is the first row, and for recall, the denominator is the first column. So it will be 130 plus 80. So it will be 210. Okay. So it will be 0.64, and it will be 0.62. Okay. Similarly, you can calculate. I am just writing it now. I hope you already understand. So it will be rainy. For precision for rainy will be, what will be the values? It will be 233 by also above 150, and recall of rainy. 150 in the denominator. It will be 224. I hope you understand how this 223 and 224 come. So this 223 come from the summation of this from this row, and this 224 come from the summation from this column. Okay. So it will be 0.64. It will be around 0.67. So the calculation may be slightly wrong, so just check. But yeah. Similarly for here also, the precision for foggy class, it will be precision for foggy class will be this 120 by 200, and for recall the foggy class is 120 by 170. So it will be 0.6, it will be 0.71. Similarly for precision for clear, precision for clear is this 155 by 255. Sorry, it is 155 by 255 and recall. And recall will be what is the class? Clear. So recall will be 155 by 237. So this value is 0.61 and this is 0.65, I guess. Okay, now you know all the precision and recall for individual class. Now you know all the precision and recall for individual class. Now it's very easy to calculate the value. So what is the first question? The first question is like the macro average precision. So what is about macro average precision? So macro average precision will be the average. So it will be the average for all the precision. So it will be the average of all the precision of all the precision values. So what are the precision values? So this for this class, this for this class, this for this class, this for this class, this. So you just need to add these 5 values, 5 different precisions, and divide. So it will be the sum of all this thing and divide by 5. So if you just do this thing, you will get around it will be around 0.642. Okay. If you just add this 5 value and then divide by 5, it will be 0.642. Okay. So 0.642 basically, I guess, see, so there are some decimal issue and all this. So basically it will be similar to the C, option C. So it will be the option C. Oh yeah, so solution answer is option C. Solution is not. And the second question is the macro average recall. So same thing. So macro average recall, what is it? Then you need to average. So basically for the same thing, you need to average of all the recall values. So basically you need to sum all the recall value and divide it by 5. So what are all the recall values? So this one, the square boxes, this one, this one, this one, and this one. If you just sum this recall values and divide it by 5, it will give you 0.646, like something like that. Okay, so 0. So the first option is, so option will be the correct answer. So I hope you get the thing. So first you need to from the actual table. So from the actual table you need to calculate the individual confusion matrix for individual classes, and from there you need to calculate the individual precision and recall. Okay. And then finally you just need to average all these values. So this is a kind of the whole process. So for macro average. Okay, so this is the macro average and macro precision and macro recalls. Now the next question they are asking, what is the accuracy of your classifier? So accuracy is pretty easy. So how to calculate the accuracy? If you just see, so what is the accuracy? So basically if you just see the diagonal, so diagonal of your actual table, so the diagonal value, so the 5 values, so 130 plus 150, 150, 120, 120, 155. So basically the diagonals are so what this diagonal represent in the actual matrix. So if you are not, so if this table is like seems kind of clumsy, so let's check the actual table. So here only, so what is this the diagonal suggests? So this diagonal suggests ki number of time the goal levels and predicted levels are same. Okay, so for the first, if you check the first cell, so it is the number of times sunny, the prediction is also sunny and the goal level is also sunny. If you just check the second entry in the diagonal, it is the number of time the prediction is windy and the goal level is also windy, so which is 150. Similarly, if you just check the third element in the diagonal, it is 150. So basically it is number of time the prediction is rainy and the goal level is also rainy, and so on and so forth. So basically the diagonals are represent the diagonals are will give you the count, total count. When what is the count? At the count is the number of time your prediction match with the goal levels. Okay. So basically this is the thing. So basically what is then accuracy? Accuracy is that number of time you have so basically yeah. So what is this accuracy? Accuracy formula is pretty simple. So in the numerator, number of times. So I'm just writing hash. So number of times you are correct divided by total number of time. Total number of prediction and whatever. Now if you just see, so what is the how to calculate from the actual table? So if you just recall the actual this 5x5 table, so that was given for all these things. This 5x5 tables are given. So yeah, so the numerator will be the diagonal. Okay, so diagonal entries. Diagonal entries from this table, from the table. So from the confusion matrix. From the confusion matrix. And the denominator, what is the denominator? Denominator will be the sum of the sum of all entries. Oh, sum of all entries in the table. So from this confusion matrix, sum is CM, so confusion matrix. Okay, so so then if you can just sum up this thing, so it will be 130 plus, so yeah, so 130 150 plus 150. If I'm wrong, just let me know. I can write it wrong. So 120 and 15, and if you just sum over all the cells, so I have already tell you the total sum is 1098. Okay, so the total sum is 1098. Now you just need to, so if you just sum it, it will be 705 by 1098. So if you just do the sum, it will be around 0.642. Okay. So basically this is the accuracy. So this is the accuracy. So yeah, so the first option 0.6421. Yeah. Okay, I hope the first three is clear. Now they are asking what is the micro average precision. Now previously they are asking macro, now they are came into micro thing. How to calculate the micro average? If you remember, so how to calculate the micro average? Can anybody tell? Okay, so yeah, so how to calculate? So basically from the actual confusion matrix. So what is the flow? Basically from the actual confusion matrix that has been given to us, so which is like this, which is this which is this 5 cross 5 matrix. From this 5 cross 5 matrix, what we have done, we calculate the individual confusion matrix. So individual confusion matrix for each of these classes. So each of these classes we just calculate the individual confusion matrix. So true, false, so prediction and gold, okay, for each of these things. So this rainy, windy, whatever are this sunny, I forgot all these things. All this thing has given. So for all this thing we calculate the for 5 different weathers we calculate the individual confusion matrix. And how we calculate it, I already shown you all these things. So I already shown the whole procedure. Now we already have these different 5 tables. Now from this individual 5 tables we calculate the individual precision and recall. For each of this table we calculate the individual precision and recall. So I'm just telling you the whole flow. And for macro thing, what we have done, so how to calculate this thing. So suppose this is the precision for first table and this is the recall for first table. So it is P2 R2, P3 R3, P4 R4, P5 R. So what we have done, so for macro precision, what do we do? So sum over P1 plus P2 plus P3 plus P4 plus P5 divided by 5. Similarly for recall, same thing. Summation for all Ri's divided by 5. Same thing. So this is for macro precision and macro recall, how we have calculated. Now they are asking for micro thing. So how to calculate this micro thing? So basically then we need to calculate again a single table from all these tables. So basically it will be again a 2 cross 2 matrix. So again it will be a 2 cross 2 matrix. But the entry for, suppose, what about the entries then? So it will be again true, false. So what about the entries then? So entries basically the sum of the, so for this cell, for the first cell, it will be the sum of all this first cell. Okay. So basically if this is the cell 0 0, okay, so if it is cell 0 0 for table 1, it is cell 0 0 for table 2, it is cell 0 0 for table 3, table 4, it is table 5, then it will be this entry will be the sum of all these things. So it will be the sum of all this C00 I. So what is the I? So I will be from 1 to 5. Similarly for this also, this will be the summation for this second cells for all these tables. For third cell and fourth cell. Similarly you can calculate the cell. So now you have the ultimate cell, and from this cell you calculate the single precision. You calculate the single precision and recall. This precision and recall are micro. Okay. So I hope you got the flow. So from this individual confusion table, you calculate the final table by doing the summation from individual cells, and from this table you calculate the precision and recall, and which is micro precision and micro recall. Okay. And if you just do it for, like, if you just okay, where we have done. Okay, so if you just so basically we have these 5 tables. So if you just do it here, I'm just writing it here only. So you already calculated. Yes. So it will be, so the final table will be, I'm just, the space is small, so I'm just writing it here. So it will be the sum for all these 5 cells. So basically if you just do the summation, it will be 705, 393, 393 and 413. And from this table you will calculate the precision recall. and this precision and recall will actually the micro precision, micro recall. So how to calculate the precision and recall? If you just remember, if I just remove a small space here, so just remove a small space. So basically, how to calculate the so basically, what will be the precision? So precision will be total number of time your prediction. So this side is prediction, and this side is gold. So total number of time you predicted true. So this thing. So in the denominator, total number of time you predicted this thing. So it will be 750 plus 393, and in the numerator it will be the when the true prediction and the goal level are same. So it will be 705. Similarly for recall, the numerator will be the same 705, but the denominator this thing. So total number of time, the goal level is like the goal level is correct. Like you predicted the goal level. So how many times? So this is sorry, not the prediction. So how the total number of true the goal level predictions. This column only. Okay, so it will be 705 plus 393. Now you can see this micro precision and micro recall are same. Okay, so the micro precision and micro recall are same. Now another important interesting thing, if you just remember, this micro precision, micro recall and accuracy are same. So if you just see, so it will be 705 by, if you just calculate, it will be 705 by 1098. Similarly, recall will be same, 705 by 1098, and if you just remember, the accuracy is also 705 by 1098. So what we have get? So accuracy is like micro recall and micro. Okay. Okay, so yeah, so if you see the accuracy, what we got, the accuracy is 0.6421. So basically average precision also will be same thing. Yeah, so if you just see, the answer is B. So the 6A 7B are same thing, and I hope the recall also will be the same. C, yeah, 8C. So all these are 0.6421, 6421, 6421, 6421. Okay, so I hope this is clear. So if anybody has any doubt about this calculation, precision recall, how to calculate from the actual confusion matrix, how to calculate the individual confusion matrix for individual classes, and what is this macro and how to calculate this micro, you can ask. I hope it is like I elaborately described the whole flow. Still, if anyone has any doubt, you can ask. Else we will move to the next question. Okay, so yeah, so this is basically the probability kind of a question. So yeah, what is this question is asking? So the question is asking it is estimated that 40% of the emails are spam emails, and some software has been applied to filter these spam emails before they reach your inbox. A certain brand of software claims that it can detect 98% spam emails and the probability of false positive. So what is false positive? False positive is like, so basically you are like wrongly predicting the same thing like spam. So basically here what is positive class? So here the positive class is like detecting something spam. And now what is false positive? False, you are falsely detecting it as a spam. So basically it's a non-spam, but you are predicting it as a spam. So and which is a 3%. Now if an email is detected spam, then what is the probability that it is in fact a non-spam email? So basically they are like, then they are asking, so given, you detected a email as a spam, but what is the probability it is actually non-spam? Okay, so they are asking this conditional probability. So okay, so let's do it. Okay, so basically if I can write it as this way, so spam, so this is spam, and maybe I'm writing it as a, I can write it as a denominator. Okay, so because so SA, so SA, because SA basically okay, so the mail is actually spam. So that's why I'm just giving this subscript as A. So basically this A represent actually. Okay, and then I'm just writing SD. So it is mail you detected as spam. So basically SD is the mail you detected as spam, but it can be in reality it can be spam, it can be non-spam, but you detected it as a spam. So there are two different events. So the first one is SA. So SA is the event so when the mail is actually spam, and SD when the mail you detected as spam. Okay. Now take the different probabilities. So what are the probabilities? So the first, they are saying ki the 40% of the emails are spam. So it is given. The 40% of emails are actually spam. So this is given. So so this thing is given. So probability of SA is 40%. So basically if you can write it like 0.4. Okay. So this thing is 0.4. Okay. Now yeah, this thing is given. So obviously you know what is the probability ki the mail is not spam. So it is just the inverse, so it will be 60%. It will be 0.6. Okay. Now what are other thing given? So given ki a certain band of software color, it detects 98% of the spam emails, and the probability, okay, so they are saying ki it can detect 98% of the spam emails. Okay, 98% of the spam emails it can detect. So what they are saying ki probability of detection of a spam email given it is actually spam, okay, is 98%. So basically it is 0.9. So I hope you understand the notation. So this notation suggests that given it is actually spam and then your software detected it is spam is 98% with probability 98%. Okay. And what are the last, sorry, what are the last thing that has been given? So it is given ki probability for a false positive. So what is false positive? What is false positive? Ki, that is given in the brackets. Ki actually, so the mail is not spam, but you are detecting as a spam. Okay. So the probability, actually it is not spam. Sorry. So actually it is not spam. So actually it is not spam, but you are detecting it as a spam. I hope you understand the notation. So the given the mail is actually not spam. So SA is actually spam and SA dash is not spam. Actually not spam. Then and you are detecting it as a spam, so which is 3%, which is 0.03. So all these things are given. Now they are asking what is the probability? What is the probability if a email is detected as a spam, but it is actually not spam? Okay, it is actually not spam. So you detected as a spam, but it is actually not spam. So they are asking the probability. So what they are asking? So the probability keyword, you detected it as a spam. You detect it as a spam, but it is actually not spam. So that is the thing they are asking. If an email is detected as a spam, then what is the probability? It is in fact a non-spam email. So yeah. So you detect it as a spam, but what is the probability? It is actually a non-spam. Now you can use the base rule. I hope you know what is the base rule. So it's a very popular rule in probability. So what this rule suggests? So basically, if you see, so basically this rule is in the denominator will be probability of SD, in the numerator it will be probability of SD given is a dash. Okay. So this thing, this is the thing. So I'm just writing the what is the base formula. So base formula of P A I of already you know, but still I'm writing. So for probability of P, probability of B given B is probability of B given A into probability of A. And what is B? So basically, if we just x this thing. So the probability of B is like probability of B given A plus probability of B given A prime, not A, and probability of A. This is the probability form. So this is the total. So this is the total thing in the denominator. Okay. Now if you see how, so what are the different values you already know. So you know this probability value, this thing. You know this thing also from here, but you don't know this thing is probability of SD. So what is SD? So the total probability that you detected as spam. So you don't know this thing. So total, so the probability that you detected a mail as a spam. So how to calculate this thing? So in the numerator it is fixed. So it is basically you predicted it as a spam, and it is actually spam. It can be possible. So there are two only possibilities how to calculate this, calculate the probability. What is this SD? So basically the total number. So the probability that you detected a mail as a spam. So what are the different possibilities? The first possibility is like it is actually spam and you detected as a spam. Okay, so this is the this multiplication of this whole thing. And the second thing is that you detect it as a spam, but it is not spam. So it's not. So I hope you understand this part. So how to calculate the whole thing. Okay. So basically, if you just take the this thing PB, so how can you get the PB? So PB can be, so it can be a two way. You can get PB two way. One is you get PB given A, and you get B, but it's not A. So basically, this is the summation of these two problems. Now if you see how many values are already you know. So you know this value, you know this value, you know, yeah, this thing is all. So this thing is already known, and this thing is already known. Now if you just put all these things together, all these values together and multiply the thing, you will get the correct value, so the correct answer. Just do the math. Okay, so just put all these things together. I hope it is 0.03 into, what is this, 0.6 in the denominator. This is 0.98 into 0.4 plus 0.03 into 0.6. If you do the calculation, I hope it is around this 0.04 or something like that. You just check 0.4. Yeah, the C numbers is kind of numbers. Just check. Okay, I hope this part is clear. I hope this is more or less this probability. Okay, and the last question is pretty easy. So this is nothing about this question. So it is about this rouge score calculation, rouge 1 and 2 calculations. So recall. So they are asking to calculate the recall value only. So given a if you remember from the lecture, so how to calculate the rouge score. So one summary is given and there are multiple reference summary. So this R1, R2, R3 are the reference summary, and this S is that summary that you have generated, or system, whatever the thing that system or whatever the thing they have generated, and you need to compare it with this reference summary. And by this, like how to compare. So this, for this thing, this rouge scores are there. So how to calculate this rouge score? So basically rouge 1, rouge 2, basically this 1 represent the unigram intersection between the generated summary and the reference summary. And similarly rouge 2 is the reference, like the diagram commonality between the system summary and the reference summary. If you just let's do it for just one simple step. I hope it is very easy. Okay. Okay, so this is your system generated summary, and this is the first reference. So what is the sentence? Sentence is the quick brown fox jumped over the lazy dog. The quick brown fox jumped over the lazy dog. And what is the quick brown fox jumped over the lazy dog? What is the first reference? The fox jumped over the dog. The fox jumped over the dog. Now how to calculate the rouge score? So there are other R2, R3. So let's calculate the rouge 1. So rouge 1. So the unigram. Okay, so what will be in the denominator? Denominator rouge 1 recall. Okay, so rouge 1 recall. So it's not other thing. So they are asking rouge 1 recall. So basically this is the total number of unigram in R1, R2 and R3. So you just calculate the unigram. So in the first thing, so in the first question, if you just 1, 2, 3, 4, 5, 6. So R1 has 6 unigram, R2 has 1, 2, 3, 4, 5, 6, 7 unigram, and R3 has, so 1, 2, 3, 4, 5, 6, 7, 8. So so total, what is the total number of unigram? So it is 6 for the R1, 7 for the R2, 8 for the R3. Now in the what will be the in the numerator? Numerator will be the intersection between the between the R1 and system plus R2 intersection system plus R3 intersection system. So basically intersection means unigram intersection. So if you just check the first system and R1, so it will be the and the is common, quick is not there, brown is not there, fox is there, jump is there, over is there, the is there, dog is there. So there are 1, 2, 3, 4, 5, 6. So this will be 6. So the first will be 6. And similarly you can calculate the second part and third part. Okay. Second, so the intersection with the second art, like the second reference. What is the second reference? The brown fox leaped over the dog. The brown fox leaped over the dog. Now check. I'm just writing tick here. So the is there. Brown is there. Fox is there, jump is not there, over is there, the is there, dog is there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Here also it is 6. So here also it is 6. Similarly, you can calculate for the R3 and you will just sum over all these things and you will get the value for rouge. Similarly for rouge 2. So rouge 2 basically the same thing. It is like in the denominator it will be the total long of bigrams. Total long of bigrams in the denominator. In the numerator is the intersection of the bigrams. Okay, so R1s plus R2s plus R3s, but it is about intersection about the bigrams. So it is of the bigrams. So here it is the unigram intersection. Here bigram intersection. So what will the denominator? So if we just check. So basically the bigram thing, simply you can calculate from unigram. If you just subtract 1, it will be give you the bigram thing. So in the unigram it is 6, 7, 8. So it will be 5, 6, 7. Okay. Basically how to calculate the bigram? So basically this, if you just check. So this is a bigram, this is a bigram, this is a bigram, this is a bigram, this is a bigram. So 1, 2, 3, 4, 5. Similarly for it, this is a diagram, this is a diagram, this is a diagram, this is a diagram, this is a diagram. So 1, 2, 3, 4, 5, 6, 6. Similarly, if you calculate the R3, it will be 7. And you can calculate the intersection for this thing. So let's check the bigram intersection between R1 and system. So the quick is not anywhere. So the quick is not there. So is quick bound is anywhere? Quick bound is not there. Brown fox is anywhere. Brown fox is not there. Fox jump is there. Yeah, fox jump is there. Here it is fox jump. Here also it is fox jump. Then jumped over is another bigram. So jumped over is there. So jumped over is there. Then over the is there. Then over the is there. Then the z and this nothing match. So there are 3 bigram matches from R1 and S. Okay, so similarly you can calculate with R2 and system, and you can calculate that rules too. Okay, so I hope it is very simple. Just it is already they have calculated all these things, so you can check it out. I hope you get the concept how to calculate the whole thing. Okay. And I also wanted to discuss some of the last year questions, but I don't know if you want to. So this let's discuss just one question. So I hope you already know how. So if you just remember this LEXRANK and all these things, so you don't need to calculate all these things. All these things will be given. So basically let's do it for a simple program. Okay. Okay, suppose this is the question that has been given to you. So what is the question? Question is that consider the following test case for summarizing a document with 4 sentences, T1, T2, T3, T4, and their relevant scores are already given respectively. The redundancy scores are already given. Also all these things are given. Now they are asking if the length of each sentence is L and we want a summary of length 12. So find out the optimal extractive summary. Okay. So basically what they are saying, let's so basically they are saying in your document, so basically this is your document, so there are 4 sentences, T1, T2, T3 and T4, and each of with length L. So this is length L, this is length L, this is length L. Now they are asking you need to make a summary. Okay, you need to make a summary and a extractive summary. So, and what is the condition? So the total in this new summary, the total number of sentence will be, the total length will be 12. So what is this 12 means? So basically you can only accumulate 2 sentences. So in your summary there can be only 2 sentences among these 4 sentences. Okay. Okay, so among these 4 sentences you can only accommodate for 2 sentences. Okay, so how you can choose these 4 sentences? So 2 sentences, basically there are 4 C2 ways. So if you just, what is this 4 C2? 4 factorial, 2 factorial, 2 factorial. So basically 24 by 6. So there are 6 ways. This can be your summary can have only 2 sentences. So one can be T1, T2, one can be T1, T3, or it can be T1, T4. It can be T2, T3, T2, T4, or T3, T4. So there can be only this 6 ways you can use your summary. The sentence can be like the orders are not like ordering is not matter. So it can be T2, T1. So basically, so the only thing is that like in your summary there can be only 2 sentences. Now they are asking you what is the best summary. So what is the best choice from this out of these 6 options? What is the best choice? So is it T1, T2, 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 T3, or what is this? So they are asking to get the best 2 choices from these 4 sentences. So basically, so there are actually 24. There are 6 such combinations, and among these 6 combination, you want to get the best one. And how to rank them? So that's why, if you just remember, so there is a LEXRANK algorithm, and from this LEXRANK algorithm you will get the relevance score for each of this individual. So basically from this LEXRANK thing, so if you just remember from this LEXRANK thing, you will get the individual informativeness for each of these sentences. So T1, T2, T3, T4, for each of these things you will get a information score. Oh, so these things are already given here. So these things are already given, 3, 2.2, 2.2. Okay, so it is 3, 2.2 and 2. So it is given here. Now also what is given? The redundancy. Basically what this redundancy matrix shows. So what do we need? Why we need this redundancy matrix? Suppose you select, so what from this informativeness you can change. Okay, so T1 is very informative, it has score 3, and T2 is also has score 3. So basically let's take T1 and T2. So these two totally give me the score of 6, because 3 plus 3 is 6. So we can take the summary as T1, T2. But the problem is that it can be possible that the T1 and T2 are very similar kind of sentence. Okay, so then your summary will be kind of redundant. Okay, so it is not that good. So the 2 sentences are maybe individually 2 sentences are very important, but they are kind of redundant. Like if one sentence present, then other like the other sentence is not that necessary. Okay, so that the two sentences are redundant. So to avoid this case, how to then that's why in this kind of thing, so people give they will give you this redundancy matrix. So what this redundancy matrix says, so the first row is about the first sentence, and these scores are how much redundant the diagonals will be always 0, because like the same sentence the redundancy is 0. Now for the first sentence, the what is the redundancy between the first sentence and second sentence? 0.5. What is the redundancy from first sentence and third sentence? 0.5. So this is this way this redundancy scores are given. Now how you can calculate the total score for each of these combinations. Okay, so if you just if I just write it like this way, so score of T1 and T2, so basically it will be the individual information score of T1 plus information of T2 minus there will be some parameter and the similarity between T1 T2. So basically you need to add this information for T1 and T2, but you need to subtract the redundancy score. Okay, so yeah, so basically this is the score for how you can calculate the score for two sentences. Okay, for three sentences you can add another term. There will be three other terms, so that way you can include. But for the two thing, you just add the information score for these two individual sentences, and then you can subtract the redundancy for this. Now in this example, they already giving you the 4 options, so you don't need to calculate all the 6 possibilities. Okay, so they are only giving you these four sentences. You just calculate the individual score for this thing. So T1, T3, T3, T4, T2, T4. So all these things are given. Let's calculate the score for each of these things. So if we just delete. Okay, so what the first option is T1 T3. Okay, so first option is T1 T3. So what will be the score? So it will be T1. So what is the score for T1? 3. So it will be 3. Then the score for T3, what is the score? 2.8 minus lambda into redundancy. So I think lambda value is also given, so it is so lambda value is not given here. So just think of it as 1 here. Okay, so just think of it as 1. Okay, so they will mention, but just for the time being, so suppose lambda is 1, so just you need to subtract the similarity. So the redundancy, basically redundancy. So the redundancy score of T1 and T3. So how to get this score? The matrix is already given, T1 and T3. So this is the first row for T1 and T3 is 0, this column, so it is 0.5. Okay, so it will be 0.5. It will be 3 plus 2.28 minus 0.5. If you just calculate, it will be 5.5 minus 5.5 minus 0.5. It is 5.3. Okay, so the information for this T1 T3 is 5.3. Now calculate for T3 T334. T334. T334 it will be what is the score, individual score for T3? 2.8. Same for T4, 2.8 minus the redundancy. So what is the redundancy T334? So T3 T4 is 0. Okay, so it is 0. Okay. T3 T4 it is 0. So it is 0. So if you just do it, it will be 5.6. Okay. Then the option is T2 T4. T2, T4. So what is the information for T2? It is 3. What is T4? 2.8. And what is the redundancy between T2, T4? Just check the matrix. T2 is the second row and the 4 is the last column. So it is 0.1. T2, T4, 0.1. Okay, so it will be 0.1. So if you just do it, 5.8 minus 5.7. Similarly, what is the last option? Last option is T1, T2. Okay. So T1, T2. So what is the score of T1? 3 plus T2 is also 3 minus the redundancy between T1 and T2. So what is the redundancy between T1 and T2? First row, second column, 0.5. So it is 0. So 6 minus 0.5, 5.5. So there are 4. We got 4 values for 4 different combinations, and among this 5.6 is 5.7 is the largest, and its corresponding combination is T2, T4. Okay, so T2, T4 will be the best summary if we only select 2 sentences. So T2, T4 will be the best summary if we only select 2 sentences. Yeah, so T2, T4 is the correct option. Okay, so in the exam they might give you such kind of question where they will give the individual relevance score and also the redundancy matrix, and you need to calculate this kind of thing. So if they will give you, maybe they will give you 5 different sentences and they are asking what will be the best summary with only 2 sentences, you need to calculate the different combinations, and for like the combinations for which the score is maximum, you will select, okay, so this combination is the best summary if we only select the 2 sentences. Such kind of questions they can give. Okay, so this is all for this week. I will upload the video in the YouTube and also upload this document in the Drive. And if you have any further question, you can ask, or we can conclude it. We can meet in the last week. So this is the 11th week, so you only have another week, so 12th week. And yeah, so if you have any question, you can ask, or we can meet next week, next Tuesday as well. Okay, so I hope you don't have any further doubt, as you are not asking anything. So I hope you understand all this question, all this thing. Okay, then let's conclude the meet, and yeah, thank you, and meet next week. Till then, goodbye, best of luck. Okay, so bye.